All right, guys, this is going to be 9.3 special right triangles part 2. So there's one other special right triangle, and this one's called the 45, 45, 90. So we just finished going over how unique the 30, 60, 90 was. And so now we're going to do the second special, and there's only two. This is the second special right triangle, 45, 45, 90. So let's see how unique this one is. So we're going to investigate this triangle from the square. It's going to be derived from the square, okay? And so both of these figures are squares. So let's examine this first one over here. So what I want you to do is I want you to draw one diagonal, okay? And because when we draw that diagonal, remember all of these are right angles, but when we draw that diagonal, that forces these angles to be 45 and 45. And so there's my special right triangle right here. Okay, now remember this other side is going to be the same because all four sides are equal in a square. And so what I want to do is I want to figure out this hypotenuse. So let's use Pythagorean theorem because we have 2 out of the 3 sides. And we're going to leave our answer in simplified radical form. So 2 squared plus 2 squared equals c squared. 4 plus 4 is 8. And then we're going to square root. And we're going to simplify that a, which some of y'all probably have this memorized, that the square root of 8 is 2 radical 2. So I'm going to write that right here on the hypotenuse, and that is 2 radical 2. Okay, so lots of 2's. So again, just like there was a pattern on the 30, 60, 90, there's probably a pattern here as well. So let's investigate it one more time. So let's draw another hypotenuse. Here's my 90-degree angle. Here's my 45 and 45. This is 5 also. So that's the easy part about this. This is a 45, 45, 90. And when two sides are equal, it's also known as an isosceles triangle. So this is also referred to as an isosceles right triangle. All right, let's do Pythagorean theorem. 5 squared plus 5 squared equals c squared. 25 plus 25 is 50. Square root both sides. I'm going to do 25 times 2. Circle the 5s, underline the 2. So the hypotenuse was 5 radical 2. So let's highlight and focus on these values. So this leg was 2, this leg was 2, and the hypotenuse was 2 radical 2. This leg was 5, this leg was 5, and the hypotenuse was 5 radical 2. So do you guys think that if I have another 45, 45, 90 triangle, and let's say this was 3 and this was 3, what do you think the hypotenuse is going to be if we follow this pattern? 3 radical 2. Okay, and that's the pattern. So this one seems to be a lot easier than the 30, 60, 90. Okay, so let's look at this pattern and continue it on this table. So we have, if each leg is 1, then what's the hypotenuse going to be? 1 radical 2, or just radical 2, because you technically don't have to write the 1 out in front. Okay, if it's 2, the hypotenuse is going to be 2 radical 2. And this one would be 3 radical 2. And this one would be 4 radical 2. And 5 radical 2. So see, this one is a lot simpler. And L radical 2. Okay, so let's write out the conjecture. In an isosceles right triangle, also known as the 45, 45, 90, if the legs have the length of x, which let's go ahead and write it on this picture over here. Remember, they're always going to be the same, okay? Then the hypotenuse is going to have the length of x radical 2. And so this is how you're going to see it on your formula chart using, they'll give you this exact picture right here. And so what about some formulas to think about, okay? So if we're ever going to solve for the hypotenuse, that means we probably know the leg. And so all we do with the leg is times it by radical 2. What if we're given the leg, okay? I mean, what if we're trying to solve for the leg, which means we're probably given the hypotenuse. So what do we do to the hypotenuse? We take that hypotenuse and divide by radical 2, okay? And so here's where you're going to have to remember how to divide by radicals, just like we did on an assignment not too long ago. And that's pretty much it. So let's see how we can see this on problems, okay? So remember, you always want to ask yourself, what did they give us, okay? And so here on this first example, they gave us a leg, and the leg is 4. Well, getting the other leg should be super easy because these are always the same. And then when it's a nice, pretty whole number, the hypotenuse is always just 4 radical 2, or whatever the leg is, okay? This one's also pretty easy because this is in the form of radical 2. So each leg is just going to be what this coefficient is, which is 8, okay? Or if you think about what I said, whenever we're given the hypotenuse, we want to divide by radical 2, and those cancel out, okay? So now it starts to get a little bit different, though. So it doesn't look like radical 2 over here, but we're given the hypotenuse. So what do we do to the hypotenuse to get a leg? Well, I just said that a second ago. We divide by radical 2, okay? We cannot leave a radical in the denominator. Technically, this is our answer, except for the fact that we can't leave it in this form. So you learned what to do, and that's multiply by radical 2 over radical 2, which equals 12 radical 2 over 2. You can simplify these right here, so you need to take care of that. 2 goes into 12 6 times, and so this is simplified as 6 radical 2. So that is my leg right here, 6 radical 2, and both of them are always the same. Okay, so let's take a mental note of this as well. When the hypotenuse is a nice simple whole number like 12, look what the coefficient was. The coefficient was half of the hypotenuse, and you had a radical 2. Okay, so that's something to always think about because this is probably going to be a pattern. Let's try the next couple of examples. So not so pretty problems, but whenever they give us the leg, it should be super easy. And you always want to make sure that that's simplified all the way, and 6 is. So the other leg is going to be the same, 3 radical 6. Now, what do we do to the leg to get the hypotenuse? Okay, just like we said earlier, if you look at this formula, we do the leg times radical 2, and that'll get us the hypotenuse. So I'm going to take the leg, and I'm going to times it by radical 2. So you multiplied radical, so that's going to be 3 radical 12. Now, if you leave your answer like that, you're going to get it wrong because this 12 can be simplified. So that's the last thing that we need to do. So we're going to take the 12 and do the little tree, 4 and 3, 2 and 2, underline. And so don't forget, we have the coefficient out there of 3. This 2 is going to join it, so this is going to be 6 radical 3. Okay. Now, is it a coincidence, or do you think it's a pattern that these two are flip-flopped? Okay. I would not assume that these always just get flip-flopped. So we can actually check to see if it does the same thing here in this next problem. Okay. Okay, so in this next one, what did they give us? They gave us the hypotenuse. What did we say earlier to do to the hypotenuse to get the leg? And that's to divide by radical 2. Okay, now you see a radical being divided by a radical. You always want to check, can you simplify those? The answer is yes, you can divide a radicand into another radicand. And luckily this goes into it evenly, which makes life easy. So this would just be simply 3 radical 3. 3 radical 3, 3 radical 3. And so you'll notice it doesn't follow this pattern over here where you just flip-flop. Okay, so if some of y'all were thinking this was going to be 6 radical 3, that would be incorrect because when we did the math, this is what we got. All righty, last problem that we will do, I think. Nope, we've got a couple more. So again, given the hypotenuse, we're going to follow this same pattern over here. We have 6 radical 27, and all we're going to do is we're going to divide that by radical 2. Now, I recognize that 9 is divisible into 27, so I'm going to come over here off to the side and reduce it before I multiply by radical 2 over radical 2. So watch me do the factor tree over here. I'm going to do 9 times 3. 3 and 3, circle, underline. So this new hypotenuse, new numerator up here is going to be the 3 is going to join the 6, so it's going to actually be 18 radical 3 over radical 2. Now what do? We want to multiply by radical 2 over radical 2. And so we're going to get 18 radical 6 on top and on bottom over 2. Does the 18 and the 2 simplify? Yes, they do. That's going to be 9 radical 6. So the legs are 9 radical 6 and 9 radical 6. Okay, so just because you have something here, they're not always going to simplify these for you. So you have to always make sure that you simplify. Okay. All right, let's try a couple more. Now, hopefully you got pretty good at this. Let me remind you, let me go back to this one over here. Remember, this was a nice simple whole number. And what happened to the coefficient and what were the legs? This coefficient was half of 12. So let's remember that so we don't have to do a whole lot of work. What is half of 9? 4.5 radical 2. 4.5 radical 2. That's what each leg's going to be. Okay, same thing goes for this one. Well, actually, let me prove this to you just so you can be sure. Remember, we take 9 and we divide by radical 2. We cannot leave radical 2 in the denominator. So we're going to get 9 radical 2 over 2. Now, if you wanted to leave your answer like this, that's fine. But think about it. What is 9 divided by 2? 4.5, like we had said. Okay. So there's two ways you can do this. You can remember that, oh, we just take half of the hypotenuse if it's a nice simple whole number. If it's a radical, you know, be careful with that. Okay. And that's it. How about we try it for this one over here? It's, yes, it has a variable, but still you can take half of this. Half of 6x squared is 3x squared. And then we're going to times it by radical 2. So those are your two legs. Oopsie. Okay, and if you want me to show proof over here, I can do that. 6x squared. We need to divide it by radical 2 because that's what we do whenever we're given the hypotenuse. You cannot have a radical in the denominator. So we're going to multiply 6x squared times radical 2 over 2. Does the 6 and the 2 simplify? Yes, they do. 3x squared radical 2. So see, you don't have to show all this work if you remember this pattern always. The coefficient, when we're given a whole number in the hypotenuse, for the hypotenuse, all you have to do is take half of that and put that as a coefficient of radical 2. Okay, so, and that is it.